Okay, so we've got piecewise functions. We're going to take our trig, and also you guys can see that some of those functions on there, do they have some trig in them too? Some of them are kind of a review of older functions. Some of them have some trig in them. Piecewise functions can be built of anything. So there's like no limitation on what you could put in a piecewise function. Any function you've ever seen can go in there. So a piecewise function, the way I like to think about it, is it's a combination function. Some people call it a composite function. So you guys got some little notes already built up for you there. So I put stuff that makes sense to you in those blanks. So a piecewise function I like to think of as a combination function. It can take any number of different functions that we've already studied and put them together kind of into one whole. They are extremely useful for computers. All kinds of computer-based stuff works on piecewise definitions. So it can be an infinite number of different functions. It can be 2 functions only. It can be 7 functions. There's no limit. Okay. The thing that is limited for a piecewise function is where each piece is drawn. Because remember, when you put one thing into a function, how many things are you supposed to get out? Just one. So if something's designed right in piecewise land, each piece is only defined on one domain. Okay? So I think in my notes I said each is defined on a limited domain. If they overlap on their domains, they're not really a function anymore. That's the problem. So one of the ways to think about such a function is to consider it to be composed of 2 structures. This is totally the way I think about it, but I've had success in the past with students. So there's kind of like a what for the function, and there's like a where for the function. Does that kind of make sense? So we're going to do like 2 out of each of these ones together. So this is the one that was on that video you guys watched the other day. So here's our first one we're going to work with. So can you guys kind of see that there's a what and a where? How many pieces does this have, by the way? It's always a question I ask at the beginning.
6.
Who's feeling pretty strong? Herlin's feeling pretty strong. 6. I hear more 3s, Herlin. You got the class against you this time.
No, there's 6.
Think about the what-where issue, though. These are the what. There's 3 pieces.
There's the what.
And this is the subdomain for each one, where it applies only. Does that make sense? So there's really only 3 pieces. Each piece has a what and a where. A what and a where. A what and a where. Does that kind of make sense? And if I defined this correctly when I made these all up, then when you put any x value in from -infinity to infinity, it should only go in one piece, because then I'm going to get one thing out only. Okay? So I asked you guys to find where each function was defined. These first ones, we're not going to draw it quite yet. We're just going to plug stuff in. So let's have a look at that. Oh, what's that last blank under part 1 you guys see? For each problem below, evaluate the function by plugging into the appropriate one. Remember, in function land, one input, I already kind of said it, right? Produces one output. Okay, so I just kind of picked some semi-random stuff. Not really, but... So I said to plug in these things. And see what comes out. Okay? So, 1.5. Which piece does it get plugged into? Because it's only going to go in one.
X to the 3rd plus 2.
1.5 is between -1 and 2, right? So it gets put into this function. So I'm going to get what? 1.5 cubed plus 2. We might need our calculator on that one, so grab your calculator and get that one. We're going to try to avoid using our calculator today, but we might use it a couple times. knew that looked funny. I looked at it and I was like, wait. Okay, so -2. Where's that going to get plugged in?
3x minus 8.
That's here, right? It's less than -1, so it goes here. So that's 3 to the -2 power minus 8. That's one we should be able to do without our calculator. Negative exponent means what? Flip, right? So this is 1/9, or 1/3 squared, minus 8. So that's going to be like -7 point something, right? What is it? You guys tell me. What's 1/9 minus 8? It's like -7 and 8/9, but I don't like mixed numbers. -7.8. What? Oh, what do you have, John? Like that? Okay, sweet. Okay, -1. We've got to think about, all right, where's -1 fit in? What do you guys think? Which piece?
Negative x cubed.
This piece, because it's equal to -1 on that edge. So I'm going to go -1 cubed plus 2. That's -1 plus 2. That's 1. Okay. If I put 6 in, that's clearly bigger than 2, right? So we're going to use the bottom piece, the line this time. So we're going to have half of 6 minus 4. That's 3 minus 4. That's -1.
So for all these problems, would you like us to write it out like that?
I don't really care. I want the right answer, so it's kind of up to you, Courtney. I think this would be best for sure. Yeah. So most likely. 2. Which one of these two is 2 going to go into?
1/2 x minus 4.
Well, it's equal to on this one, right? So it's going to go in the line. Half of 2 is 1 minus 4. What's that? Minus 3. Oh man, that's a bad minus. Okay, there we go. Okay, so we're going to draw this one in just a second. Let's go and do some more evaluating, though. I figure I will do 2 of each of these for you today, and you can kind of finish the rest. That's the idea. Okay. So number 2, h of x. Let's look at h of x. This was f of x. You guys can start working on those ones for h of x. So h of x has a little trig in it. It's 5, or it's a negative sine wave, or it's a tangent that has a change in period. It's 5 if x is less than -pi. It's the sine wave between -pi and 2pi, and it's the tangent if it's bigger than 2pi. And I asked us to look at 0. What if we put 0 in? What if we put -2pi in? What if we put pi in? 4pi, 3pi, and 2pi. Okay. So, what do you guys think? If we put 0 in, which piece?
-3 sine
0's in here, right? So it's the sine wave one. So I'm going to go -3 sine. If I put 0 in, 2 times 0 is 0, right? And then that's a unit circle calculation. So you guys either tell me in your head or draw it. What is the sine of 0? 0 is right here. Sine is the y coordinate. What's the y coordinate right here? 0. So this is -3 times 0. 0 comes out. 0 in, 0 out. And we can start plotting points to start graphing this, right? That's probably not a very efficient way, but we could. All right. All right, what if we put -2pi in? Which piece is that going to go into? Yeah. So is there like a place to put it? It's just 5. 5 automatically comes out. That's a flat line. When we graph that in a second, you'll see it's just flat at 5. Does that make sense? There's nowhere to plug it. It's just, that's what comes out. Everybody always has trouble with that for some reason. Don't freak out about it. It's easy. Pi. Where's pi?
-3 sine.
That's the sine wave again. So now I'm going to put pi in, and it'll be 2 pi inside. Again, that's a unit circle. Where's 2 pi? Right here, same spot. Again, what's the y-coordinate right there? 0. So this is -3 times 0, which is 0. So see on these ones, Courtney, in regard to your question earlier, I think it's pretty good to have it written out. If you don't, I'm betting you'll mess up quite a bit. If it's something with trig especially. But it's kind of up to you still, okay?
Go to the next one.
What do you got, Herlin?
Tangent.
4 pi is going to go in tangent. He's right. Tangent of what?
1 over 2.
2 pi.
2 pi. There we go. Heard it from Drennan. Very nice. Because half of 4 pi is 2 pi. You could write out another step if you like. What is tangent of 2 pi? You can think about your graph or your unit circle.
Undefined.
Let's do this one with the unit circle. Tangent's y over x, right? 0 over 1 is 0. Jake?
For h of pi, would it be tan with the 1.5 x? Because the x is less than 2 because it doesn't say equal to or
For this one, right?
Yeah.
For 1 pi, isn't 1 pi between -1 and 2 pi?
I read that wrong. Oops.
That's what it is.
It's fine. Does it make sense now, though?
Yeah.
Okay.
I looked at the 2 pi on the slide.
Oh, right, because there's a 2 in there.
Yeah.
Good question. All right, 3 pi. If I put 3 pi in, that's going to be tangent again, right? So I'll have tangent this time of 3 pi over 2, right? If I put a 3 pi right there. Tangent to 3 pi over 2, that's one you should think about. You should know that from your graph. If you have regular old tangent, doesn't 3 pi over 2 hit an asymptote? So this is undefined. If you don't like doing it that way, come back here. 1/2, 2/2, 3/2, 0, -1, y over x. That's undefined. Okay? 2 pi, if I put in, is going to hit this edge. So it'll be the tangent. 2 pi over 2 is pi. I think if you know your graph well, tangent of pi is 0. That's an x-intercept. Or you could go ahead and go back to the unit circle. Okay? So there we go. One thing in, one thing out. Now we could start using those points to graph it. I think that'd be kind of a pain in the butt process. We'll try to make it a little easier in a second here. So tonight, you guys are going to do the same thing for those other 2 problems. I'm going to leave that to you. What's your assignment for tonight? Why don't we go to part 2? So you guys can finish those other 2. I just want to get to part 3 today. So part 2, I would like you with a partner to take about 7 or 8 minutes and use your notes, use the text, use each other. Go to the back page of your notebook where you're keeping your notes and do a quick sketch and name all the library of functions that we've done this year. If you have them all in the front of your notebook, you can use that. So I think that we should have all the library of functions: logarithm, exponential, tangent, sine. Real quick, I'm going to give you 8 minutes to do a quick sketch of each one, just to get it in your mind. Okay? Okay, so this is the first one. We want to graph f, and then I think we'll graph h. You guys are going to graph k and beta tonight. Okay, so what do you guys think? The first piece, I've also got a little direction process. I heavily suggest you stick to my direction process there. You don't have to, but I think it'll make your life a lot easier. So there's like 3 steps. First step is what?
Find the lowest and highest x values for the restraints.
Yeah, but let's follow the thing. Like, what's it say to do
Draw
first?
the first subfunction.
So first subfunction. Let's just go and look at that one. Okay. So we'll draw the first subfunction. I'm not going to look at anything else. That's it. So this is what kind of function? I think it's like one of these. It's an exponential growth, and the minus 8 shifts it down 8. So its asymptote is going to go down 8. So I'm going to go down 8. 1, 2, 3, 4, 5, 6, 7, 8. About right there. Draw the new asymptote. And then I'm going to start growing from there. If you guys remember your exponentials, they always go like they intersect 1 higher. Yeah. So I'm going to like draw it. It's going to do something like this. Intersect at -7 and keep going up that way. Now, step 2 on your graphing directions says what?
Value the first subfunction at any applicable edges on this domain.
So basically, use the edges of the domain. Even if this is not filled in, that just means the edge is going to be an open circle instead of a closed circle. Plug that in regardless. Plug in the edges. So if I plug in this edge, I get 3 to the negative 1 minus 8. So that's a third minus 8. We can use our calculator or whatever. I think that's like negative 7 and change. Okay? So that's like right here, yes? Right here. And open or closed circle on this edge. It says not equal to, so it's going to be an open circle right there. And then my third direction, the last part for each thing, is do what? It says erase portions of the function not in the domain. So now you guys tell me, there's the edge. What side do I erase? Do I want to erase left, or do I want to erase right?
You want to erase
So
the
your
right.
x is less than.
Yeah, I want to
erase
I want to erase all the stuff on the right of that, because it says we want this function if we're less than negative 1. Does that make sense? You boys get that? So, and you want to label your edges. Like sometimes it'll be really obvious what the edge's label is. This time I don't think it's very obvious, so I'm going to definitely label that edge. So I'm going to say that that edge point is negative 1, negative 7 and 2/3. There we go. If it's super obvious, you don't have to label it. Okay, you'll see it's obvious at some point. Okay, then we're just going to repeat. So we say, okay, next function. This is a snake function, right? Cubic snake function shifted up 2. So I'm thinking snake function shifted up 2. So it's going to go through right there. It's going to be something like this. I'm not real sure yet. So then I go to step 2 and I plug in the edges. So I've got 2 edges to plug in this time. So I'll do a little scratch work right here. I'm going to plug in the edges. So I'm going to put in negative 1. And I think some of this work we kind of already did at the beginning. So that's why I picked some of those points. So I think that's going to give us 1. So at negative 1, it should really be going through right here. And what do you guys think? Filled in or not? Filled in. And I'm going to erase all the stuff to the left of that because I only want the snake function between negative 1 and 2. So I'm going to be erasing this part of it as well. Does that make sense? How high does it go? How am I going to figure that out? Take 2, plug it in. You always want to plug in your edges. So now 2 cubed plus 2. What is that? 8 plus 2? So we got 10. So this guy will go all the way up until 10. So I guess I should put a spot right here. What do you guys think? Open or closed circle on that one?
that should be, yeah.
Open.
Open. And I should be going up to that, snaking up there. Does that make sense? And I'm going to label my edges. 'Cause, well, this one's pretty obvious. Maybe I don't need to label that. This one's not so obvious, I guess. So 210, I'll label it. And then I've got my last function. My last function is, of course, our oldest friend, the line, right? It's just mx plus b. So you could graph the whole line if you want. It's kind of up to you. See, this is where it starts to get to be your personal choice. You can graph the line and go, okay, 1, 2, 3, 4. Start with the y-intercept and go up 1 over 2, right? If you want to do it that way, you can, and then just erase the part of it you don't want. Let's do it that way. So it'd be something like this, right? Pretty shallow slope, half. Okay, my edge that I want on this guy, though. So I'm going to plug in 2. So I get 1 minus 4. So negative 3. So at 2, I should really be at negative 3, and it should be filled in. So right there. And what do you guys think? Do I want to erase the part on the right or the part on the left? It says I want the line function
On the right.
if I'm
On the
bigger
right
than
one.
2. Yeah,
You wanna keep
exactly.
it,
I
yeah.
want to keep that part. There you go. Label my edge. I should put an arrow on this side because it's going to keep going. And there you go. I'm done. Piecewise function done. I know it's a function because it passes the vertical line test. If I put that in, I get that out. If I put that in, I get that out. If I put -1 in, I get that out. That's why this has open down here. It's got to be, or this wouldn't be a function. If I put 0 in, I get 2. If I put 2 in, that's open. Oh, I get the -3, and then I start continuing on this piece. Okay? So there's one example. Let me do one more for you. This last one is kind of, I think it's artistic. You guys can tell me what you think when we're done, okay? I was feeling it when I made this one. And some of the other ones are pretty neat too.
He's feeling it.
Gotcha.
You guys can tell me if I'm like a super huge dork when we're done or not, okay? Like, be honest, okay? Can I see you?
Yes, sir.
So let's look at h of x.
Huh?
Why you gotta be like that?
Okay, same process. So use that process that I gave you. If you're getting lost, go back to the process and see if you can figure out where you got stuck, okay? That's why it's there for you. Okay, so the first function's real easy. It's just 5, right? Y equals 5. Is y equals 5 like this or like this? This is x equals
Horizontal.
5, right? So it's horizontal. Okay. I'm gonna get a pretty big axis on this one. This is where my video stopped working. Okay, so we'll go through the process. Draw the first subfunction. We could draw y equals 5 the whole way across. I'm going to kind of shortcut this time though, right? Like, I don't want the whole thing. What part do I want?
All the parts that's what?
Where am I going to split it at?
-pi.
-pi, that's right here, yeah? So right there, what do you guys think? Open or closed circle?
Open.
Open circle. And do I want the part less than or more than pi, -pi?
Less than.
I want the part less than. So I could go like this. Now if you're really following my instructions completely, you'd have just drawn it all the way across, you'd have plugged in the edge, and you'd have erased this part. Does that make sense? I thought this one was kind of easy enough without it. It's pretty obvious where this is, so I'm not going to label this edge judgment call. Okay? All right, next piece. It's a negative sign function. So let's do some thinking. Its amplitude is 3, and it's the negative's going to mean instead of starting up, it's going to go down. Okay, the period's a little different, right? What is the period of this guy? It's going to be, help me out.
Pi.
Pi, because you go like this, right? So its period is going to be pi. So it's going to be done every time we get to a pi. And I want it between here and here, so it's going to be like from here to here. Does that make sense? Questions on that? You can again just plug in the edges, but here I think again it's easy to just read. This says between that spot and that spot. So I'm going to just start by graphing it right here. And you guys said it's going to go down first, right? And it'll be totally done by the time we get right there. So I'm going to go down how much? 3. So I'll go like down 3, up 3. There's one cycle. Yeah? And then I think I'm going to go all the way to 2 pi. So I'm going to go down 3, up 3, and it kind of ended in a nice spot. That's how I make this. And then this one is going to keep going back, right? So up 3, down 3. And I think that's it for it. And again, do you guys think I need to label the edges on this one? No, I mean, they're obviously 0, right? I did make one little mistake though, technically. I did. One tiny little mistake. It's pretty teeny. What's an open circle, Selena? This one.
Oh, yeah.
Yep. Otherwise, I think we're good. We got the middle piece. I shouldn't really have done these in different colors because this is all just one function, right? So, my bad. I will keep using different colors for each piece though on this one. Okay, so then tangent. This is almost plain old tangent. Its period is different though. What's this guy's period? It starts as pi, divide by our half, and I heard the right answer back there. Let's get 2 pi. Okay, so this tangent's kind of wider than usual. If you remember your tangent, we straddle, right? But now it's going to be like right here. You guys see it? Pi each way. But I don't want it over here, right? I just want the tangent for this area over here out to infinity. So it's kind of up to you. If you're having trouble, then draw in some asymptotes. Use them as scratch work. I'm going to draw this one right here, just so I'm clear. And then Devin, what'd you say? You said I should put another one where?
At 3 pi?
At 3 pi. Perfect. Now this is 2 pi wide, like we wanted. Does that make sense? And then the next one would be, this one's at 3 pi. We didn't even really need this except to figure out where this one was, right?
Yeah.
You can leave it though, I mean, it's fine. And the next one would be at 5 pi. Exactly. And it would keep going from there. We'll only draw a cycle or two. So, if it's tangent, it's always going up.
No, it's going down.
Right, so,
Is that right?
do I want this piece though?
Huh? I was wrong. Oh, it's cotangent
Tangent's,
going down?
cotangent's always going down.
Oh, my
Yeah.
bad. Tangent goes up then.
Tangent's going up, right? Something like this. But I don't want this piece of
Yeah.
it, you see what I mean? It says start drawing tangent when you're bigger than 2 pi, which is right here.
So
that's right here.
start in the little hole?
And this one has the quality, I made this function connect. Since that's equal, that fills in that hole. Piecewise functions don't have to connect, but they certainly can, and in lots of real-world applications they do. And then it keeps going, right? So it's got more periods. And it would keep going for more cycles. You guys see how I connected it up though? Is it like artistic or not? I tried. You can do all kinds of stuff with this later on. So I tried to make a lot of your functions be kind of interesting visually. Okay? So we've got like the flat piece, the sine wave piece, and this one just coincidentally, because I made it that way, connected to the tangent piece. Okay? So there you go. So what you guys are going to do for tonight is graph or attempt as best you can to graph those other two. And they are a little challenging, so we'll go over those tomorrow if we can. Okay?
The worksheet there.
What's up? Yeah, and you don't have to worry about part 4, so we'll look at part 4 and we'll take our quiz tomorrow. That's the idea. All right? I've got another worksheet on this, but we're going to do that like Wednesday, Thursday.
I'm gonna go back, guys.